So that must concern you from a regulatory perspective then with the NAB's latest push for the government to mandate ATSC 3.0 for 2028, 2030.
We do not want a sunset, a mandatory sunset. So we took our station in Boston, WCRN, went 3.0. I spent 17 months on this and then said, forget it, we're going back to 1.0.
I just had a discussion with Frank Copsidas of XGen, who is behind the deployment of 5G broadcast in the United States and has also traveled all over the world and seen test demos there. 5G broadcast, in a lot of respects, is a competing standard to ATSC 3.0. ATSC 3.0 has a lot of technical advantages over 5G broadcast, but there are many, many advantages to 5G broadcast that cannot be overlooked. The ATSC tries to downplay the 3GPP's impact on mobile devices and being able to include potential 5G broadcast support. For those of you that don't know, 5G broadcast is a broadcast standard. It is just like ATSC 1.0. It is just like ATSC 3.0. It is a one-to-many broadcast standard. Doesn't require the internet, doesn't come from cell towers. It comes from broadcast towers, just like ATSC 1.0, just like ATSC 3.0. One of the things that stuck out to me the most was how much of a hard time he had with ATSC 3.0 and trying to deploy ATSC 3.0 with his station that he tried it out at versus everything that was done with 5G broadcast. And the consensus, I think, from the last interview that I had done with Andrew and John from XGen a year and a half ago, is how much easier it is on the broadcast side to get things up and running with 5G broadcast compared to ATSC 3.0 that is more complicated and is in some ways more stressful for the broadcaster to start to accomplish. Another thing that I talked about with him is just the fact that mobile devices are crucial for the future of broadcast. You know, we need direct to mobile for broadcast to survive. And he agrees that linear television broadcasting in a lot of ways is dead. So anyway, here's my interview with Frank. All right. Hi, Frank. And thanks for doing this. If you want to introduce yourself.
Always good to see you, Dylan.
Same here.
My name's Super Frank Copsidas. I am the CEO of XGen Network, which our whole mission is 5G broadcasting. We've been on it for 2 years now, full time, and are very excited about the future of it. I'm also president and founder of the 5G Broadcast Collective, which is a nonprofit to educate people around the world about 5G broadcast. Then the other side of my life, we own and operate 7 television stations in the U.S. So that's
great.
my back.
That's awesome. I think the first question right out of the gate that I want to ask you is just the existential aspect of mobile broadcast. So regarding just mobile broadcast with a history of it, more generally, it is almost somewhat depressing based on everything that has happened in the past with media flow, with LTE broadcast, with all of these other technologies that were poised to be ATSC mobile handheld, another example, that they were supposed to be the future of direct to mobile broadcast. What, in your view, makes 5G broadcast different?
Okay, first of all, we're broadcast one to many. So
Yeah.
when you get into LTE broadcast, it's still pretty much one to one in some form or another. It isn't true broadcast. So 5G broadcast actually works because it's already on the chip. There's no additional chip needed on the boards. In that chip, you have many different kinds of 5G. So I always say 5G is like Baskin-Robbins ice cream. It comes in 31 flavors, and every flavor is completely different. So on that chip, you have satellite, you have cell, you have 5G broadcast, you have side link, you have many different things on there. It's which ones are opened up to function and which ones function with each other, right?
Yeah.
So the big start for us is we're on the chip. We need eMBMS for LTE as we stand right now. That's pretty much on a lot of chips. Just needs to be enabled, aka licensed. And then as long as the frequencies are on there, it pretty well works. Our next phase is FEMBMS, and we're still in the LTE world. Even though it's called 5G broadcast, its true name is 4G LTE 5G broadcast. We get to true 5G broadcast when we're in 5G NR, and then we're going to use MBS as opposed to FEMBMS or eMBMS.
Great. My question would be, other than, I believe, the RF front end that would need to be upgraded on most consumer devices, other than that, and just making sure that the spec is perfect, and of course the antenna, which I think, especially if you have low band 5G, I think the antenna requirement wouldn't really need to be that strong because you could reuse the existing array that's already there for the low band 5G and probably still have.
On the transmit side, you're talking?
No, on the receive side for the
Receive.
mobile device.
Yep.
Yeah. Not for the broadcast side, you want to have that gain as high as possible, obviously, but for the
Sure.
receive side, I think just from a manufacturer's point of view for like what would need to be done to get that in there
We're in
more.
the middle of doing that right now, so I can talk. Let's go to the transmit side because it's so easy to kind of deal with. Right now, if you have your broadcast station and you have an OFDM capable transmitter, which means you purchased it probably 2017 or newer, it would be OFDM. Then all you need to do is replace the exciter and the modulation software. That's a very, very easy transition.
Yeah.
Use the same controller, same amp, same coax line, same antenna. Everything works. Theoretically, this is less than half a day to convert a station over to 5G broadcast, and boom, it's ready. Now, the receiving side. So there are two kinds of receivers we deal with, right? One is a smartphone. The other is any kind of CPE, customer provided equipment. So let's go to the smartphone side first because you were talking about it. And your challenge in a smartphone is the amount of real estate you have in that smartphone. The smartphone's small factor. So the fact we're already on that chip is what makes it doable. If we needed another separate chip, like ATSC 3.0 does, not doable. There's just not that real estate available within the chip or within the board. So what has to be done? Band 108, which is the broadcast band as defined by 3GPP, is from 470 to 690 megahertz. That's a large amount of frequency to tune into and optimize. So basically in the US and India, we're in 470 to 608 megahertz, and Europe is pretty much in the 606 to 698. So last December in the 3GPP meeting in Madrid, we put in a proposal and it actually got approved to have two sub-bands under 108, each one with the one for the US, India, and one for Europe. This way, when manufacturers go to make those phones, they can tune them to the right, optimize them to the right set of frequencies. Now, for the European model phones, there's very little that needs to be done if eMBMS is opened up and a couple other things are done. The antennas are already pretty well tuned in because you have band 71, which is the T-Mobile band in the US, but band 71 in Europe is still broadcasters. So if you are already tuned in, all you need in the system, the operating system of the phone, is you need it optimized to receive 5G broadcast receive only mode in those frequencies. But those frequencies are already tuned in on the phone because cell uses it. So the European model's easy to do, boom. US models are just slightly more difficult. So right now, those frequencies are not opened up on the chip. What does opened up mean? It means they're just not tuned in. It doesn't mean they're not there, they're just not activated to be received. So number one thing you have to do is activate 470 to 608. Number two is the antenna array needs some adjustments. So when we're talking adjustments, we're not talking inches, we're talking very small amounts. And depending on the size of the phone, it can be difficult, it can be not difficult. So in our QRDs from Qualcomm, which are development phones that we use right now, those are normal smartphones and it can be done pretty easily. No, it can't be retrofitted easily, but it can be manufactured. If you're manufacturing from square one, it's not a big deal to adjust those antennas. We are months away from the first commercially deployed 5G optimized smartphone in the world. And it's a rugged phone. The first model that comes out will be for Europe in those bands. Then once we know it's working right, we'll optimize it for the US, meaning opening up those frequencies, tweaking the antennas, and optimize reception for 470 to 608. Those phones are rugged phones, and the idea is to use those for first responders. Those phones do have a return path, so if you need to verify information was delivered, you can do it through Wi-Fi is the return path. That is the only return path right now. But having been at MWC, Mobile World Congress in Barcelona a couple weeks ago, one of the big moves forward is a lot of the IoT chip manufacturers are now looking at smartphones as well. So IoT in the past was a bigger chip, needed more real estate, so it was only in bigger boxes for CPEs. Today, those IoT chip manufacturers are looking at smartphones. They've gotten small. One of them is now 9 millimeters by 9 millimeters, their chip. The big difference is in the new chips coming out next year, the chips can do LTE and 5G NR simultaneously. Not dual processor. One processor can do both. So all of a sudden you could receive in LTE and return path through 5G NR. So that is a huge, huge change for us. We expect those chips out first quarter next year. Second quarter, they'll get put on boards and probably out to OEMs for manufacturing. I would guess by third quarter next year, 2026. Right for that 2027 rollout.
Sounds awesome. Can you elaborate a little bit? Yeah. Can you elaborate a little bit on the Xiaomi product that was tested in France during the Olympics? Because I know that, I think it was like a somewhat hacked together 5G broadcast phone. It wasn't fully set from the manufacturer, had a little bit of tweaking to achieve it. If you want to explain that.
So the Xiaomi phones, as just about every cell phone has band 71. So it's not the full 608 to or 606 to 698. It's more like 615 to 698. So some of the lower channels are not able to receive 5G broadcast in Europe because of band 71 restrictions. So first of all, you have to operate in band 71 for these test phones. That's the start. The second thing, they had to optimize the phone somewhat, again, to receive 5G broadcast. And that's done in the operating system. So that would be the OEM doing that.
Okay.
The actual manufacturer of the phone, in this case, Xiaomi. So Xiaomi put out 250 phones for tests for the Olympics. It worked really well. TDF in France had a number of transmitters up around the country as well as on the Eiffel Tower, and it went extremely well. Now they're doing pop-ups around France to demonstrate it to the public. So not only in Europe, not only do you have Xiaomi doing this, you now have Motorola doing QRDs. Those were used in the demos in Brazil. You have OnePlus doing them in Austria. You have Samsung just releasing QRDs. So they're all development beta test phones. But the big thing, it's on their radar, right? Motorola is putting out test phones. Samsung is putting on test phones. So they are working on it. And another really interesting kind of sideline on this is when I was at 3GPP in Madrid in December, we found out that Apple actually is starting to look at it. So, talking to Apple is like talking to a wall, right? There's no information.
Yeah,
but
I can imagine that.
A little information came through that were on their radar. So that was a big breakthrough for us.
Before you know it, an Apple Pencil, who knows?
Who knows?
Yeah.
Who knows?
Yeah, that was a very interesting video that I made talking about the patent. Super interesting stuff, especially coming from Apple of all companies. And I think it shows that they've got their gears turning there, about the potential of the one-to-many model.
Yes, absolutely. For example, for them, where would it really come into play? Where could it benefit them? So let's go to Miami and MLS, right? You have all those people in the stadium trying to stream the game. And the problem is everybody tries to stream. What happens? Cell network goes down.
Exactly.
So what they can do is deliver the game with various angles, by the way, through 5G broadcast. So you as a viewer can choose which angle you want to look at. There are all kinds of options in here that are already developed, done. Or it goes through cell. But there's seamless switching, which has been proven it works, no problem. And what seamless switching is when that feed for the game comes through, it looks at how many people are demanding this feed. So the stadium just opened and 2 people have tuned in. Well, makes more sense to go to cell. But all of a sudden, 10,000 people are tuning in, you go to 5G broadcast. And you can switch back and forth. The algorithm looks at it every half second to decide which is the best and most efficient way to deliver that signal. And it can switch back and forth, and you as the end user will never know which way it's coming. So why do that? One, cell phones service stays working, and number 2, cost of delivery goes way down.
Yeah, that's huge. And I think another thing that you could compare this to with Apple is, they've got rights to Major League Soccer. So, if CDN costs are high for their MLS, subscribers tuning into that, I mean, that could be an avenue for
Absolutely.
them as well because they're technically a broadcaster of sorts with their Apple TV program. So,
Right.
yeah,
And they're basically the only big company that doesn't have a last mile solution. Amazon's doing both fiber and satellites, right?
yeah.
Google does fiber. You have a lot of solutions being bought up by the big guys. Apple so far hasn't entered that field.
It'd be very interesting if they went the multicast route for that.
Yep.
Something
And
that,
also, you have to take into account net neutrality, right? Because net neutrality goes away, the cost of delivering those programs goes way up.
yep. Yeah, and I mean, if they want to go with green energy goals too, with being able to supply, I think one of the most amazing things about the one to many model is just how efficient it is in terms of energy consumption. I
Yes.
mean, it's a technology where the more people that you have using it, the less energy demand it takes to send it, which is incredible. And especially for companies to achieve their, energy goals and their net zero goals, broadcast is almost required in, a modern mobile connected world. So I look
Right.
at things from just from a physics standpoint. I mean, there are literally limitations to physics with the Shannon limit, with spatial multiplexing. There's literally only so much physical space that you could spatial multiplex. There's only so much, bits that you can put in a radio channel. And broadcast just makes sense with our inevitable demand for more data. Offloading things that were, consuming that unicast pipeline and allowing more unicast, more individualized unicast connections. I mean, shouldn't that be the future of mobile connectivity? It just makes the most sense.
Absolutely. Plus, using a TEM software right now, we can get a 720p signal to a smartphone, which will
It's good.
look like 8K, right?
Yeah.
It's a small picture. We can do that in 300 kilobits per second.
What
So,
codec are you using?
no compress. I have no clue.
No clue.
That's above my pay grade.
Yeah, actually, one of the things that I like about phones in particular, and I actually started talking about this on my channel, is with ATSC 3.0 right now, because of things, I mean, just on the mobile side of things, I'm not going to deny that ATSC 3.0 is a mobile standard because it is. But 5G broadcast is just so much more capable right now, and I know the ATSC has kind of gone their way and said that no, 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 it's actually not that difficult. It really is more difficult compared to the 3GPP standard since everything already uses it. But
Right.
I mean, at this point, the only way that a mass adoption of ATSC 3.0 in phones would be happening is if India mandated it. And then they're like, okay, every single phone now in the country or in the world, not just in India, but the whole world is going to have ATSC 3.0, technical ability. But what really, grinds my gears about ATSC 3.0 is the fact that we're tied to these set-top boxes with very low-end SoCs, very low-end, basically technology that is just good enough for the year it was made in. And that's how a lot of TVs are built too, because
Yes.
the TVs, their margins are so small. So they're going with the most cheap components. And when it comes to something like efficiency with broadcast, that's incredibly important. So what I was trying to explore is, could versatile video coding, the latest next gen codec that's super efficient, could you apply that codec with software decoding on one of these set top boxes or on one of these TVs? Would it be able to handle it?
Forget set-top box
Yeah,
TV.
they couldn't.
So what we're hearing is that CES next year in January, we're going to see a TV from a major manufacturer. Don't know what one. This is all I know. What I'm telling you, with a 5G chip in it.
Really?
Yep.
5G unicast cellular or broadcast?
We don't know.
Okay.
All we know is the 5G chip. If we knew who that was, we'd be all over them to make sure they were opening it up correctly with FEMBMS.
Well, yeah, I mean that's the future we should be going in is, not having to connect wires to things, having to be able to just have a TV and just have it start receiving data. I mean, that's always
Right.
been my vision with broadcast is you just, you plug in a Roku stick and the Roku stick has a built-in antenna receiving broadcast signals and you just tap a button and you just start watching it. No need for the
And
consumer to have clunky antennas, installing things and with the technology and making sure that signals are robust enough and things of that nature, we could achieve that relatively easily for a significant portion of the population.
so one of the major things for me, going back to ATSC 3.0,
Yeah,
first
definitely.
of all, 3.0 needs a separate chip in a phone. It cannot be part of the current chip. So that is its biggest obstacle, right? Also, 3.0, so somebody asked me at MWC, hold it, 3.0 works perfectly in South Korea. Why doesn't it work in the US? Well, South Korea has one standard, and they got their act together with one standard. In the US, it's a group of broadcasters who put it together, and they all sat at the table, and they all got everything they wanted. Well, it's like trying to write a song and putting every instrument in. There's going to be interference in frequencies. It's not going to sound good. Well, ATSC 3.0 has challenges working. So, as president and founder of the LPTV Broadcasters Association as well, if there's a new standard, I personally feel I have a responsibility to try it out. So we took our station in Boston, WCRN, went 3.0 using a TEM and NSYS hardware and software, and two of the world leaders in broadcast technology. And then when it didn't work, well, it was July we installed it. December I was told it's going to be at least another 6 months till it works properly. I'm like, okay. And then we went to another company, used their technology. I personally, out of my own pocket, spent $60,000 in labor getting people in, trying to get it to work. And what does get it work mean? So we're talking about a video signal and data delivery at the same time. We were lucky to get a good video signal down, or maybe we could get some data down, but we couldn't get both by any means, and we couldn't get a solid feed of video or of data. I spent 17 months on this and then said, forget it, we're going back to 1.0. So we brought the station back to ATSC 1. We did another, then when 5G broadcast came along, we felt the same thing. And literally, we have installed them in half a day.
Wow.
And they work. Everything works. ATSC 3.0 throughput, more than 5G broadcast? Absolutely. Today, no question. However, again, in Madrid at the 3GPP, we put another proposal that got approved. So it's in group sessions now, in the group level, where they have to look at the technology, all that before it's approved. But it's the interleaving of time and frequency, which will bring us up to ATSC 3.0 throughput right away, as we sit today with EMBMS. And once we go to FEMBMS, we go 60% above that. So we're a new format. We're a new standard. We're 2-3 years old for all intents and purposes. ATSC 3.0 has been around 15 years, and they still can't get it to work right. Sorry, but the truth.
So that must concern you from a regulatory perspective then with the NAB's latest push for the government to mandate ATSC 3.0 for 2028, 2030. I'd just be curious to hear maybe the LPTV and your perspective if you're, willing to share.
Sure. Sure. So one of our main points is we do not want a sunset, a mandatory sunset, which we let be known in the Future of TV initiative, which happened last year. And I was on that initiative. It was the FCC NAB about the future of TV. LPTV does not want 1.0 sunset. If full power stations want to move on to 3.0, let them. But we don't want to be forced. If we're forced, who's going to pay for the equipment? The government? Right?
Yep.
Who's going to pay? We don't believe we should be forced to make that change. We feel that everybody should be able to do whatever standard they want. Why? Because if you can't make a business case for it, you're going to go out of business. So if I want to go 5G broadcast without a single commercial receiver as we sit here today, anywhere in the world, that's my decision.
Yeah.
I'm going to lose money. But if I want to go 1.0, there's ways to make money. 3.0, maybe there is. But our stand is just no mandatory sunset. And of course, I'm sure you have followed what CTA and the NAB have gotten into.
Oh, yeah.
Where CTA thinks that ATSC 3.0 is just a waste of time. Just admit you're dead. Linear TV as we know it is dead.
Yeah, honestly, I unfortunately kind of agree with that. to a
at the
point.
LPTV, breaking news.
Yeah.
The LPTV day at NAB this year, we have somebody from CTA on one of our panels talking about the future of the FCC and where TV is going, broadcast is going.
Yeah.
So that's going to be a very interesting discussion.
Yeah, I mean, just thinking of the future of using broadcast spectrum, the first thing that, really stuck out in my mind was with Wikipedia, 10% of all articles can be used by like 99% of people, because what's happening is when people are requesting Wikipedia articles, it's the same 10% on average. So if you think about it, if you multicasted and cached just 10%, that's only 10 gigabytes of Wikipedia. A public broadcaster like PBS could supply literally a part of humanity's information, right, to everybody, regardless if you have internet, regardless if you even thought, oh, I actually need to look it up because actually it's already on your device. And the best use of data is data that's already there before you even knew it, right? On device is always going to be faster than having to ping a server and, have that data get back to you.
Well, and Netflix found that with Game of Thrones, right?
Yeah.
When they first put it on. Subscribers went up and income went up, but expenses way outweighed
Way up.
delivery expenses to get to those subscribers way outweighed it. So if they could have put out Game of Thrones 2 weeks in advance, overnight, through 5G broadcast, and had it not, you couldn't play it till the release time, they would have saved a ton of money. People would have had a much better signal. Absolutely.
I think my next question for you is, how's WWOO doing since the last time I talked with Andrew and John?
So WWOO in Boston is sitting there with a brand new T-Redis transmitter ready to go on the air for 5G broadcast in our next rollout in the US, which we're thinking will be a little later this year with a group of stations. So we need to test SFNs, which are called DTSs now, which is basically a sub transmitter, right? A repeater where your signal might be weak, whatever. We have to work on, if you're traveling, the handoff between one tower and another to make sure your service continues. There are quite a few things that need testing, but we need to roll out a number of stations to do that. So we also have WXGN in Danbury, Connecticut, all set to go. All these stations can literally be on the air in a couple hours in 5G broadcast. So we are set to go with phase two. Phase two is going to be a very interesting rollout, to say the least. And we just need to wait a little longer. We do need phones available. That's probably our biggest holdup right now, but we know it's coming down the line because we're doing them ourselves. We also have CPEs, which we really haven't discussed, where real estate is not an issue. So we can make bigger boxes. It's not that big, but bigger boxes, and have the antennas tuned exactly right. And in those boxes, for example, for road signs, that's a big use case for us, especially for first responders. So if you're in a stadium and something happens, they need to change all those signs now with instructions for what you need to do. So that is one of the use cases we're working on. We did some tests in a stadium and it worked really. We had 2 days set to set up the transmit side, 2 days set to do the trials. It took us 1 hour and 40 minutes to get it working. From the time we rolled in the door till it's working, and then we actually finished all our tests in the first day.
Wow.
And we're all standing there going, we have 3 more days. What are we going to do? The answer was, go home. We're done.
Yeah, about deployments in the U.S. There were, I think, in January of 2024, some stations by HC2 Innovate Group that were supposed to go on the air. What happened to that? Why didn't they go on the air, and why is there not more, 5G broadcast stations than, just yours?
Right. So the simple answer to why there aren't more is no commercial deployment or use case yet. Not yet. We're close. We've been working on this 2 years. At the end of 3, we'll be there, right?
Yeah.
So that's why you don't see more. There's no reason to. Could we roll out our other test stations tomorrow? Absolutely. Why? We need some other parts of the puzzle to make sure we're fully functional. HC2, from my understanding, and I haven't looked at the FCC database, bad me, but I believe they went on the air with an experimental 5G station in Fort Wayne, Indiana. So they did have an application in. That application had a few corrections to be made. They made those corrections and got the experimental license to do 6 months of testing. And my understanding is they did go on the air with it, but what they're doing, I don't know.
Okay. Gotcha. I think...
Honestly, and you asked, may I ask, why don't you know? Shouldn't you know? I should know. But here's the story. I'm working with 7 other countries right now on a regular basis.
Yeah.
And my time, I'm doing 12, 14 hours a day, 6 days a week. One day I need to take off for the brain to reset, but I just don't have the bandwidth to stay on top of everything. We're close, but not quite.
Yeah, just going back to the regulatory and the push for standards in the U.S. There's a lot of people within the broadcast industry and just a lot of older consumers that conflate ATSC 3.0 and 5G broadcast as AM stereo. as dual competing standards that, there's just no way there could be dual competing standards at all, and that'll mean that it'll both fail. I don't agree with that assessment, mainly because technology is just so much more ubiquitous now than it was back in the days of AM stereo, and there are completely different applications for mobile and TVs that create that solid use case for both. So I'd just like to hear your thoughts on that AM stereo argument.
So, first of all, we do have two standards in the US right now, ATSC 1.0 and 3.0. 3.0 is not backwards compatible. So, there goes that argument right there. Number two argument, I would say, or reality, is let's look at Brazil. They did not adopt ATSC 3.0, as they like to say. They adopted certain parts of ATSC 3.0, which they call TV3.
Yep.
Right? However, the government has also said next year we're going to start rolling out 5G broadcast. They're doing both for two different reasons. They see one to be to television sets inside a home, and the other to be to mobile devices. So the reality is they can be complementary. They really don't compete. But in the US, we make up every marketing excuse we can to say ATSC 3.0 is better.
Yeah, I mean, from a technical standpoint, ATSC3 does have layer division multiplexing. It has non-uniform constellations. So from a physics point of view, in the modulation in the physical layer, there are things that are better about ATSC 3.0. I don't know if the 3GPP, I haven't read the specs that in depth if they've ever considered layer division multiplexing or non-uniform.
That's what just went in.
Was NUX.
Yeah.
That's good. That's a major step forward. I know the IEEE.
Again, they're
Yeah,
15 years old. We're 2 years old.
good. Well, when did that just go in, the NUX?
December.
Okay,
So
that's huge.
not in the standards, it's in the work groups.
In the work, that's why I didn't know. Okay,
Right.
gotcha. So yeah, that's big. Is there any development on LDM at all for like sending multiple services?
Don't know.
Okay. Yeah, because if you're using, time division multiplexing or FDM or one of those, it's always better to use LDM. It'll be more efficient. So, any argument at all that that ATSC 3.0 has over 5G broadcast, they'll be willing to make. Another thing that I wanted to ask you is, have you been deploying MIMO at all or been testing MIMO across, the world?
No.
Why is that? Just from a broadcast
We're just trying to get our basic done.
trial?
Work.
Yeah.
You want to add on the icing, get the cake done first. Right?
Gotcha.
So that's
Yeah.
what we're looking at. The other thing I'd like to say is our partners at Qualcomm said you need to go to a 3GPP meeting. And that's why I went. And I'm not a technical person. Okay? I am 100% marketing. So I went to the meeting. It's fascinating. So a 3GPP is the worldwide standard, and it's why your cell phone works anywhere in the world, because there's one standard. 5G broadcast operates in that same world, so that it is actually the first worldwide broadcast standard ever. Okay, so to get something into 3GPP, you have to present it to the whole body. Now, ATSC 3.0 did present, and we're told no, because you're a regional standard, not a worldwide standard. But what fascinated me, there were 550 people in the room. There were 800 documents to go through in 4 days, and it got done. And the way it gets done was just fascinating, and how the chairman runs the entire sessions, and how they bring something up, and you have 3 minutes to present your case. and people who want to speak for or against it have 1 minute, and after they hear 3 people who speak for it, even though there are 15 people in line to speak for it, they said, we've heard enough. Next. Those against, we've heard enough. Okay, consensus, it's not a vote, it's consensus. So they look at the room and say, anybody totally against this? Show of hands. And who's for it? Show of hands. Okay, most people for it, passed. And the other thing they have that made me crack up, there's approved, there's basically tabled for the moment. So we'll readdress it in this session tomorrow. You might need to make some changes, but there's no such thing as rejected, because nobody likes being rejected. So they call that noted. So if you see anything in 3GPP that says noted, the other term for it is rejected.
Yeah.
But we cracked up at that.
I could see that. Yeah, from just going back one last time to the regulatory, do you think 5G broadcast is going to coexist in the same 6 megahertz channel with 3.0 in the future? That's a real technical possibility, and also
that can be interleaved?
Yes.
I am told no, but I'm also told yes. So the time interleaving that's in front of 3GPP right now is not to bring in another standard. It's to increase the throughput. So could it in the future? Anything's possible. Who knows? But as we sit today, I am told no. It will not work. And if you go to DVB-T2, which was designed to kind of work with 5G broadcast, not even that works right now. You can get them to work together. The question is, how much bandwidth do you have left to deliver anything?
Yeah. There's got to be a lot of spacing.
We're stuck into 6 megahertz.
Yeah.
Europe has 8. Parts of the world have 10. Right?
Yeah.
So it depends how much bandwidth you have. So in the US at 6, I think that's very unlikely for a while.
Yeah, we've seen with ATSC 3.0, especially in the low VHF band with FM radio, that, FM radio, analog, and, ATSC 3.0 are able to coexist. I don't know if it's because of the bandwidth of FM radio is only a half a megahertz total spacing, whereas maybe you would want to do like 3 megahertz total allocation for both. If that's the reasoning, I mean, in theory, you could put the 5G broadcast where the FM radio would go in a Franken FM or an FM6 operation. I don't know, though, if that would cause too much interference. So I don't think there's really been that many tests with that, but it'll definitely be interesting.
And so far, there were a lot of tests about a year ago, but I'm not aware of any major tests going on now.
And do you know the results of those tests?
The results, I were told, no, it's not going to work.
It's not going to work
right now.
Okay.
Again, there are too many other things to do right now.
Exactly.
So let's get, maybe when the compression gets the same and then goes up 60% after that, maybe then there's enough bandwidth to do it. But that doesn't exist right now.
Yeah.
So unfortunately, it's patience.
I just think existentially at this point for 5G broadcasts, it's almost like time's ticking, because the 2028, 2030, will the FCC decide let's just go fully 3.0? And, I think being able to prove whether or not 5G broadcasts can coexist, I think, is crucial right now to, deployments.
I think 2026 will be the year where we finally have receivers, and that's when we can prove it. We can't prove it right now.
Yeah.
We have receivers. that
Yeah.
are commercially available. So that, and it's a chicken and egg, because the receiver makers, manufacturers, don't want to do it till it's
There's
being
broadcasts
broadcast,
on the air.
right? So you have a chicken and egg scenario, and that's what we're trying to do, is to facilitate that to happen at both ends.
You know, I told Dave Arland in the interview that I did with him, or the discussion that I did with him, that what broadcasters need to get mobile device manufacturers on board is to broadcast something really cool, like, 4K HDR sports, and make it super accessible to the point where a mobile device manufacturer goes, these broadcasts are on the air, we can easily implement this into our stack, and let's just do it because they're there. The quality is really good. I mean, if you're broadcasting, I hate to say it, if you're broadcasting infomercials over 5G broadcast, or if you're, over 3.0, Apple's going to look at that and say, we don't want to, like, for infomercials, for, sub channels.
Right.
So
No.
it's all about the type of, I think the type of content is literally as important as just making sure the rollout of the technology is going well, because it'll attract.
Linear TV's dead.
Yeah. Except for sports. Yeah.
And certain niche programming.
Yeah. And to some extent, cable news, broadcast news, maybe not so much, but I think cable news, there's still a aging demo with that. But sports is, I think, the best opportunity going forward. And is that something that you've looked into, like, in your local community with 5G broadcast? Would you be open to broadcasting local high school sports games, or local college games, or maybe niche sports like lacrosse, or some of these things that, yeah, because I was thinking in terms of rights, being able to acquire, the rights to that stuff, I think it would be easier, wouldn't it not?
Yeah, your audience is much smaller, but yes.
And it just comes down to that argument too. I've always said, and you brought this up too, about how, if there's not a lot of people watching programming, then unicast would be probably the best option. Just not purely from a, how many people are watching standpoint, but from a spatial wise, you're sending this huge signal and only a couple people across that huge geographical area, whereas unicast could better point and serve that stream. But, if it is something that is highly watched in a community, I think that would be a great first stepping stone, for especially low power broadcasters.
Why not?
Yeah.
Great idea.
Yeah.
So I have to thank you for inviting me here to talk to you today. And it's always a pleasure. Let's catch up again.
Definitely. If you want to do another one in the next 6 months and give me a status update or something, definitely, I'd be open.
There. Done.
Perfect. Thanks so much, Frank, for your time.
Take care.